All right, guys, welcome back. We'll move on to the next exercise, which is about perpetuities. Now, the name comes from perpetual or everlasting, and it's a special type of investment where the payment you get is only the interest that was earned on that account. So it's the exact opposite of an interest-only loan. So they do last forever, and that means whatever you put in at the start is there at the end again, because you're only receiving payments that amount to the interest earned. So it's a simple equation. The payment is equal to the interest rate times the principal. And that's you should be able to do all the questions with just that, but I'll show you how to do it on Finance Solver too. So the first example is Elizabeth. She invests a superannuation payout of $500,000 into a perpetuity that will provide a monthly income without using any of the initial investment. The interest rate is 6%. What monthly payment will Elizabeth receive? So we're using the equation as it appears above. So we need R, which is 6%, and we need VO, which is the 500,000. Okay, so there's the substitution. We can see the 6% divided by 100, multiplying it by 500,000. Let's go to the calculator and do that. Okay, so it's 6 divided by 100 times 500,000. And she gets $30,000 a month. Oh, I forgot to do something. I forgot to divide the 6 by 12 because it compounds monthly. That's better, $2,500 a month. Okay, so let's fix up my mistake here because it should be 6 divided by 12 and then divide that by 100,000. And it was, the payment is $2,500 per month. Okay, now if you wanted to use Finance Solver for this, which you could if you wanted to, the 500,000 would be both your principal value and your future value, except it'll be a negative as your principal because you're paying it into the bank, and a positive as your future value because the bank could pay it all to you or owes it to you. You've got your 6% per annum and it's monthly. So your Finance Solver would look like this. There's the 6%, there's the negative principal, there's the positive future value. I've got my payments per year at 12, and we hit enter, and we get a payment of $2,500. Okay, so for the second example, how much money will be needed to invest in a perpetuity account earning interest of 4.2% per annum compounding monthly if $200 is withdrawn every month? So there's our key information. Let's set up the equation. Okay, so this time we know that the payment is $200. We know that the interest rate is 4.2 per annum and it compounds monthly, so let's divide that by 12. And we need to find VO. I suggest you use the solve function on the CAS, or unless you're comfortable with rearranging the equation. All right, so the solve function, menu, algebra, solve. Let's type in our equation. So it was $200 was the payment. We're doing it as a fraction. We've got 4.2 divided by 12 because it compounds monthly over the 100. Then we're going to multiply that by V because we don't know what V is. We're going to solve for V. That's what you type in, you hit enter, and it gives you the answer of $57,142.90. When you write your answer down, make sure you do it to the nearest dollar as wished by the question. So I had to round that out to $57,143 invested into that perpetuity. Now, this is a question, unfortunately, that you can't use Finance Solver for, and let me show you why. When you go to fill in the fields in Finance Solver, you'll very quickly discover that you don't have the principal value or the future or final value, and you do need at least, you can only have one piece of information missing. You can't have two pieces of information missing. So for that particular style of question, Finance Solver is not going to be particularly useful. All right, in the last example, you've got a university mathematics faculty has $30,000 to invest. It wants to award a annual price of $1,500 with the interest earned from investing this money in a perpetuity. What is the minimum interest rate that will allow this price to be awarded indefinitely? So let's set up the equation and have a look. Okay, so the information we have is we have the investment and we have the payment. So let's fill that in the equation. So it's 1,500 equals R over 100 times 30,000. Again, I would just use solve to do this quickly and efficiently. So menu, algebra, solve. This time it's 1,500 equals, control divide, R, we don't know what R is, and it's over 100. Ooh, what were the compounds? I think it's safe to assume it's compounds annually, so I can just leave it as R over 100. And we're going to multiply that by, I think it was 30,000. And solve for R, so comma R. And it reckons 5%. Okay, and there's my final answer, and I've written it as per annum. So R equals 5% per annum. Okay, let's see how to do this on Solver. So I'll go back to my CAS, menu, 8, finance solver. Now my interest rate we don't know, so we're going to delete that. The principal value was $30,000. We want to get 1,500 payment. I'll change the final value as well, or the future value, to 30,000. And we're assuming one compounding period per year. Okay, let's go back up the top. We want to find out the interest rate. We hit enter. That's 5%. Okay, hopefully that helps you get exercise 9F, which is about perpetuities, done. Good luck.